Hello, today we are going to start our class with some more multiple choice questions on permutations and combinations. The first question is, I am giving you the word Cochin. Take all the letters and arrange in order like in dictionary as you see in English dictionary. So after arranging, your work is to find the number of words which come before the word Kochi. So first of all, see the word Cochin. Take the letters and arrange in alphabetical order. First C, then C, then H, then I, then N, and last O. So in Cochin, you have 1, 2, 3, 4, 5, 6 places in the word. Suppose I am taking the Cochin word here. Before this word, whatever words come, obviously they start with C. And then the remaining 1, 2, 3, 4, 5. There are 5 places which we have to fill. So, among these 5 places, see the first place. In the first place, you can have only C, H, I, and N. So, there are 4 ways to fill the first place because you cannot take O because Cochin is starting with C and O. That's why. After that, the remaining 4 places which are there and 4 letters are there because total we have 6 letters. Out of 6 letters, we have filled up the first place and the second place. 2 letters we have taken. Now we have only 4 letters and 4 places to be filled. This can be filled in 4 factorial ways. So, the total number of words we have are, the first part of the work can be done in 4 ways into the second part of the work can be done in 4 factorial ways. That is 4 into 24, that is 96. So there are 96 words coming before the word Cochin if you arrange all the letters formed as in English dictionary. Let us go to the next question. Second question. Now we have some integers. I'll give you some integers like X, Y, Z, W. And I'll give you X plus Y plus Z plus W equal to 20. I'll also tell you that X is greater than or equal to minus 1. Y is greater than or equal to minus 1. Z is greater than or equal to minus 1. W is greater than or equal to minus 1. Then, how many such integers can we have? Or how many solutions this equation can have? How many solutions? That is the question. Or how many integers X, Y, Z, W we can have. So first of all, what are they asking is the solutions for this equation. According to the information, we can take x plus 1 greater than or equal to 0, y plus 1 greater than or equal to 0, z plus 1 greater than or equal to 0, w plus 1 greater than or equal to 0. And then we will take x plus 1 as A, y plus 1 as B, z plus 1 as C, w plus 1 as D. So that you can write x as A minus 1, y as B minus 1, z as C minus 1, w as D minus 1. And one more thing, we can also say A is greater than or equal to 0, B is greater than or equal to 0, C is greater than or equal to 0, D is greater than or equal to 0. Okay, now because we have the equation x plus y plus z plus w equal to 20, x I will write a minus 1, y I will write b minus 1, z I will write c minus 1, w I will write d minus 1 equal to 20. From this I can say a plus b plus c plus d is 24. Suppose this 24 I will take as n. Then I have an equation a plus b plus c plus d equal to n. And what I am saying? I am saying for non-negative solutions for this equation. In shortcut method, I gave you formula. If 1, 2, 3, 4, 4 unknowns are there, and if you need a non-negative solution, how many non-negative solutions? You have, suppose 4 unknowns you will take as R. Then the formula I gave you is n plus R minus 1, CR minus 1. So this formula we will use. N is 24, R is 4 minus 1, CR is 4 minus 1. So that means you will have 27 C3 non-negative solutions for this particular equation. Why non-negative? Because A, B, C, D, which are solutions, are greater than 0 or equal to 0. That is why we are finding non-negative solutions. Okay, let's go to question number 3. There is a coaching institute for AIEEE exam. In that coaching institute, there are batches. Batch A, batch B, batch C, batch D. In batch A, the number of boys 25 and number of girls 14. In B, 20 boys, 15 girls. In C, 28 boys, 18 girls. In D, 35 boys, 25 girls. Now, if I want to make a leader, or one more method is if I want to give a prize. I want to give a prize to a student from batch A. From batch A. So in how many ways I can do that? So in batch A, I have boys, girls. Batch A. If I want, I can give a prize to a boy, or if I want, I can give a prize to a girl. Suppose out of 25 boys, I will select one boy for the prize. My work is over. That's it. But suppose I will add, because my work is over, I'll add the other case. From 14 girls, I will select one girl for the prize. Then also my work is over. So in that way, I'm adding both the cases, and that will be 25 plus 14. In 39 ways, I can give prizes. We can go to the next question. Fourth question. Suppose I will give you 1P1 plus 2 into 2P2 plus 3 into 3P3, so on, plus n into npn. It is equal to what? There are many options. I will write the options. First option, n plus 1 p n plus 1 minus 1. Second option, 1 by n plus 2 into n plus 2 p n plus 2 plus 2. Third option, 1 by n plus 2 into n plus 3 into n plus 3 p n plus 3 plus 1. Which option will be correct? We will see. So what I will do is, I will write the first one as just 1. 1 into 1 factorial. Then I will write 2 into 2 factorial, because 2p2 is 2 factorial. 3 into 3p3 is 3 factorial. So on, n into npn is n factorial. Now, this one I will write 2 minus 1 into 1 factorial. 2 I will write 3 minus 1 into 2 factorial. 3 I will write 4 minus 1 into 3 factorial. So on. The last n, I will write n plus 1 minus 1 into n factorial. Now I will multiply. 2 into 1 factorial minus 1 into 1 factorial. 3 into 2 factorial minus 1 into 2 factorial. Okay. Plus 4 into 3 factorial minus 1 into 3 factorial. Like this, in the end, what I will have is n plus 1 into n factorial minus 1 into n factorial. Or what I have is 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial plus n plus 1 factorial minus n factorial. Suppose if I take the first few terms, what will cancel? 2 factorial will cancel. 3 factorial will cancel. I am left off with these two terms. But instead of these few terms, if I take all, then 4 factorial also will cancel, n factorial also will cancel, and I will be left with minus 1 factorial plus n plus 1 factorial. That means n plus 1 p n plus 1 minus 1. This will be the answer, the first A. Because n plus 1 factorial, I can write n plus 1 Pn plus. So using this formula, this is what we will get. Going to question number 5. In question number 5, I will give you k plus 5 p k plus 1 equal to 11 into k minus 1 by 2 into k plus 3 pk. I have to find what is k. So NPR formula, n factorial by n minus r factorial. 11 into k minus 1 by 2 into, again same, n factorial by n minus r factorial. So here k and minus k will cancel. K plus 5 factorial by 4 factorial equal to 11 into k minus 1 by 2 into k plus 3 factorial by k and minus k will cancel, 3 factorial. Now I will write k plus 5 into k plus 4 into k plus 3 and I'll stop by factorial. Then 4 into 3, I'll stop at 3 factorial. This I'm doing because on the other side, I have k plus 3 factorial by 3 factorial. Both the sides I can cancel k plus 3 factorial. Both the sides I can cancel 3 factorial. Not only that, 2 ones, 2 twos. So I'm left with k plus 5 into k plus 4 by 2 equal to 11 into k minus 1. Or k plus 5 into k plus 4 equal to 22 into k minus 1. Or k square plus 9k plus 20 equal to 22k minus 22. Continuing here on the right side, I have k square minus 13k plus 42 equal to 0. I can factorize it as k minus 6 into k minus 7 equal to 0. So the values of k I get is 6, 7. Whatever is given in the options, you can go for that. Next, let us take question number 6. I am giving you some digits 0, 1, 2, 3, 5, 7. You have to make a 4-digit number. That too, 4-digit odd numbers, as many as possible you have to make. So first of all, if you see the first place, in the first place you can use either 1 or 2 or 3 or 5 or 7. That means total 5 ways to fill the first place. Remember, here nothing if I mention, it means repetition is allowed. I can repeat the numbers as many times as I want. So first place, there are 5 numbers I can fill in 5 ways. Similarly, the last place because it is odd number, I have to take either 1 or 3 or 5 or 7. So last place can be filled up in 4 ways. But in the middle, I can use any one of these 6 numbers, no restriction. So the middle one 6 ways, Here also 6 ways. So total odd numbers I have is 5 into 6 into 6 into 4. That means 720 4-digit odd numbers I can make. Let us go to the next question. I'm giving you 3 perfect squares as digits. I'm giving you 3 digits which are perfect squares. That means what should I give you? 1 is a perfect square, 4 is a perfect square, 9 is a perfect square. So I'm giving you only these. You have to take all the digits, all 3 digits, and form 3-digit numbers. So what I am giving you is, you have to make with these digits 3-digit numbers. After that, you have to find their sum also. Not only forming, you have to find their sum also. So what we will do is, suppose if I make a 3-digit number and if I want to put 1 here. After putting 1 here, because repetition is allowed here also, because I'm not mentioning anything, I'm not telling you don't repeat. So repetition is allowed. So after putting 1 here, first place I can take 1, 4, 9, 3 ways. For the second place also I can take 1, 4, 9, 3 ways. So that means total I have 9 numbers. How do I have 9 numbers? I'll show you. First place in 3 ways, second place in 3 ways. Total 9 3-digit numbers ending with 1. Now, if I add all these numbers, if I find the sum here of all these numbers, that means 1 I am adding 9 times. So I will get 9. Similarly, if I take 1 in tens place, the first place I can use 1 or 4 or 9. 3 ways are there to fill up. The last place I can use 1 or 4 or 9. Again 3 ways are there. So total how many numbers I can make? 3 into 3. 9 3-digit numbers with 1 in tens place I can make. So if I add up all the ones in these tens place, so what I will get? First of all, there are 9 ones, and because they are in tens place, I have to multiply 10 times. Isn't it? So like that in hundreds place. In hundreds place, the sum will be 1 into 9 into 100. In thousands place, we can't do because there are only 3 digits, ones, tens, hundreds. So the sum contributed by 1, sum of all the ones together is 1 into 9 plus 1 into 9 into 10 plus 1 into 9 into 100. In ones place, tens place, hundreds place. So instead of doing like this, I can write this in short form. What is the short form? I will take 1 common. I will take 9 common. Then what I have? 1 plus 10 plus 100. Similarly, the sum of all fours, I'll take 4 common. I'll take 9 common. 1 plus 10 plus 100. Similarly, the sum of all nines, 9 common, 1 plus 10 plus 100 into 9. So, total sum of all 3-digit numbers formed. When I take the sum, first I will write 1 plus 4 plus 9. Then I will write, I can take these two common. 1 plus 10 plus 100 into 9, I can take common. So in this way, I will have 14 into 9 into 111. That comes out to be 13,986. That is the sum of all 3-digit numbers formed. Okay, let us go to the next question. Question number 8. Yes. Question number 8. Suppose I have a number, composite number 91,000. I have to find number of ways of factoring this number into two factors. But the two factors, if you take m and n, remember m should not be 1, m should be greater than 1, n should be greater than 1. That means m is not equal to 1, n is not equal to 1. You have to take that into consideration. So for this, I gave you one formula. I will do with that shortcut formula. First of all, 91,000 I will prime factorize. So 3 threes, I can't do it. So with 7, I can do it. With 7. 7, 1, 7, 7 threes, 0, 0. Then with 13, I can do 13 into 1000. Then with 5, I can do 5 into 200. 5 into 40. 5 into 8. 2 into 4. 2 into 2. That means 91,000 I can write as 2 cube into 5 cube into 7 into 30. So these are the factors. Now, in these factors, what you can take is, what are the numbers, prime numbers you can see? 2, 5, 7, 30. We have 4 prime numbers. That means I can take n as 4. Once you take n as 4, I can say the number of factors will be 2 power n minus 1. But because I am not including 1, I will subtract 1. This is the shortcut formula I gave you. So 2 power 3 minus 1, that is 8 minus 1. 7 ways are there to factorize it into two factors in which we will not include 1 at all. The factor will not be 1 at all. Okay, we will go to the next question. Question number 9. There are 10 points I am giving you in a plane. Out of these 10 points, 6 points are collinear. 6 points are collinear. I'm giving you this. Then You have to find the number of triangles. The number of triangles, that is n, we have to find. In the options I will give you, n is greater than 190. Second option I'll give you, n is less than or equal to 100. Third option, 100 is less than n, less than or equal to 140. Fourth option, 140 less than n, less than or equal to 190. Now, because total 10 points are there, from 10 points you can select 3 points to make a triangle. Because to make a triangle we need only 3 points. If you join, you will get a triangle. But you cannot take these 6 points which are collinear, because from these 6 points, even if you join 3 points, you will not get triangle, any 3 points. So from 6 points, if you select any 3 points and join, you will not get triangle. So subtract that. That means 10C3 means start with 10, 9, 8. Take 3 numbers by 3 factorial. 3 into 2 into 1. Minus, start with 6. Take 3 numbers 6, 5, 4. Divide by 3 factorial. 3 into 2 into 1. So 3 threes, 2 fours. 3 to 6 cancel. So 3 fours 12 times 10. 120 minus 5 into 4, 20. So I'm getting 100 as the answer. So I can't take option A. I can take option B. I can't take option C. I can't take option D. Okay. So the next question is question number 10. Suppose I have a few identical balls, but their colors are different. They look identical, but the colors are different. Like there are 10 white balls, 9 green balls, and 7 black balls I have. So my question is, you have to find number of ways in which one or more balls can be selected. So you have a formula here. There is a shortcut formula. If you take this as P, this as Q, this as R, number of ways in which one or more can be selected. So P plus 1 into Q plus 1 into R plus 1. But you have to subtract the one case where none is selected. Nothing is selected because they said you have to select one or more. You can't just say, I will not select anything, and you can't sleep like that. That is why I'm subtracting this one case. Okay, so P plus 1, 10 plus 1 into Q plus 1, 9 plus 1 into R plus 1, 7 plus 1. That is 8 minus 1. So you will have 880 minus 1. That is 879 will be the answer. Okay. Next, question number 17. The next question I will give you is about triangles again. Let Tn be the number of triangles. Number of triangles formed by joining vertices of n-sided polygon. There is a polygon with n sides, so it will have n vertices. These n vertices we are taking, we are joining some of them to get triangles. How many triangles? That is Tn. Then I will give you Tn plus 1 minus Tn equal to 10. Your work is to find n. So this is very easy if you concentrate a little bit. Now there are n sides. That means there are n vertices. From n vertices, you have to take 3 vertices to make a triangle. So number of triangles Tn is nothing but NC3. You can make NC3 triangles. So from this, Tn plus 1 will be n plus 1 C3. Okay, now I gave you Tn plus 1 minus Tn equal to 10. That means I can write n plus 1 C3 minus nC3 equal to 10. Now, if you remember, I gave you one formula. Which formula I gave you? Do you remember? I gave you one formula, NCR plus NCR minus 1 equal to n plus 1 CR. This formula will be useful for us. I repeat again, NCR plus NCR minus 1 equal to n plus 1 CR. How this formula will be useful? Suppose you think this is n plus 1 CR. Think this is NCR. So what I can write from the formula n plus 1 CR minus NCR? What it will be equal to? NCR minus 1. So this together I can write NCR minus 1. 3 minus 1. 2. Isn't it? So this together I can write it as NC2 equal to 10. Start with n. Take two numbers n and minus 1 by 2 factorial equal to 10. So n into n minus 1 equal to 20. Easily you can say, you can guess, because 5 into 4 is 20. You can say n is equal to 5. This is your work. You have to find n, and that's it. That is your work. Okay. Let us go to the next question. Question number 18. The sum of all numbers formed by digits 2, 3, 4, 5, that you have to find. So do you remember I gave you one formula? What is that formula? First of all, you have to add the digits 2, 3, 4, 5. You will add. Then what you will multiply with? Because you have total how many digits? 4 digits are there. 4 digits are given to you. So you have to take 4 minus 1 factorial. And then you will multiply with what? The ones. How many ones you will write? Because there are 4 digits, you will write 4 ones. So this will be the answer. That means if you simplify further, you will have 84 into 1101 or 93,324 is the sum of all numbers formed by these digits. Next is question number 90. I will give you 5 boys and 5 girls. Arrange number of ways of arranging these people. You have to arrange them in a row. Mention that also. You have to arrange them in a row so that the condition is all girls sit together. All girls sit together. This also I gave you shortcut formula. Do you remember? First type M things. Second type N things. Then you are arranging these such that all N things sit together. All N things are together. So what formula I gave you? N factorial into M plus 1 factorial. This is the formula I gave you. So if you use that formula, 5 factorial into 5 plus 1 factorial. That is 5 factorial into 6 factorial. 5 factorial is 120 into 6 factorial is 720, and then you will get 86,400 ways of arranging. Okay, let's go to question number 20. Now again we will take 5 boys and we will take 5 girls. So you are arranging them. Number of ways of arranging them in a row. But this time I will give you condition that no 2 girls sit together. No 2 girls sit together. So how many ways? For this also I gave you formula. One type M things. Another type N things. Now no 2 N things together. That I gave you in the formula. And the formula is M factorial into M plus 1 Pn. Of course, there is a condition that M should be greater than or equal to N. But here anyways, they are equal, so we need not worry about the condition. So I will take M factorial, 5 factorial, M plus 1, 5 plus 1, 6, P, N is 5. Okay, when I arrange this, I will have 5 factorial into 6 factorial. 5 factorial means 120 into 6 factorial is 720. So again, I'm getting 86,400 ways. So if you remember the formulas, it will be easy for you. Okay, as we did the previous sum. 19th question. We are doing the next question also. Same way. Okay, we will go to question number 21. Now again, total there are 6 boys and there are 6 girls. You have to arrange them. Number of ways of arranging them in a row. The condition is they sit alternatively. Alternatively means one boy, one girl, one boy, one girl. So for this also, we have a formula. If you have n things of one type, n things of another type, and they are to be arranged alternatively, the formula is 2 into n factorial into n factorial. So if I use that formula, 2 into 6 factorial into 6 factorial. 6 factorial is 720. Again, 6 factorial is 720. So I am getting 10 lakhs 36,800 ways. I am using calculator. That is why I am able to do it quickly. Okay, next question. After 21, we will go to 22. First, we will take 4 men. There are 4 men and 3 ladies. You have to arrange them. So while arranging, we will find number of ways of arranging them. But this time, we are arranging them at a round table, not in a row, at a round table. And the condition is no 2 ladies sit together. So we have to find answer for this. For this also, I gave you shortcut formula. Do you remember the shortcut formula I gave you? For round table, suppose there are m things of one kind and n things of another kind. We are arranging them at a round table. Remember, m should be greater than or equal to n. And no 2n things come together. Then the formula is m minus 1 factorial into mpn. Using this formula, we will get m minus 1, 4 minus 1, 3 factorial into m 4p n 3. That means 3 factorial is 6. 4p3 is nothing but 4 factorial. So 4 into 24. 144 ways are there to arrange as we want around a round table. Okay, we will go to question number 23. Now I'm having 6 red roses and I'm having 3 white roses. I have to make garland. Number of ways of making garland. But what is the condition? All white roses come together. All white roses come together. That is the condition. So again, I have just like this one formula. I'll write in red color. One type M things, another type N things. Now, all N things are together. The formula will be M factorial into N factorial, and then you have to take half because it is circular permutation. So the answer for this will be half into 6 factorial into 3 factorial. So half into 6 factorial is 720. 3 factorial is 6. And so I will get 2160 ways of making the garland. Next, we can go to question number 24. In this, we are having 6 red roses and 3 white roses. Number of ways of making garland of them. But the condition is no 2 white roses come together. We have to find how many ways. So for this also, I have formula. First thing of M type, like first type, M things are there. Second type, N things are there. No 2 N things come together. Then I can take, remember M will be greater than or equal to N. I can take M minus 1 factorial into MPN. But I have to take half of it because it is circular permutation. So I will have half into M minus 1, that is 6 minus 1, 5 factorial into M, that is 6, P, N, that is 3. So I'll write half into 5 factorial. I have to write 5 factorial is 120 into 6p3. Start with 6, take 3 numbers, 6, 5, 4. So that means I can write 120 into 60. That means 7,200 ways are possible. Let's go to question number 25. In question number 25, I will give you a number in this form, a number N. 2 square into 3 square into 5 cube. And then I will ask you, 1 second. I will repeat again. Okay. I will give you a number N in this form. 2 square into 3 square into 5 cube. I am asking you number of positive divisors for this. How many positive divisors can be formed? If you remember the formula for this, P1 into P2 into P3 prime numbers. Power K1, how many times? K1 times coming, K2 times coming, K3 times coming. So what is the formula? K1 plus 1 into K2 plus 1 into K3 plus 1. This is the number of divisors formula. So now I can write 2 plus 1, 3. This power 2 plus 1. This power 2 plus 1, that is 3. This power 3 plus 1, that is 4. So, how many divisors I will have? 36. 36 positive divisors are possible. Okay, question number 26. The sum of divisors of number n. That is my question. I am giving you the number n as 2 power 4 into 3 cube into 5 cube. So again, there is a shortcut formula for this. The number is P1 prime number, P2 prime number, P3 prime number. K1, how many times it is coming? K2, how many times it is coming? K3, how many times it is coming? So if you want the sum, what is the formula I gave you? Do you remember? P1 power K plus 1 minus 1 by P1 minus 1 into P2 power K2 plus 1 minus 1 by P2 minus 1 into P3 power K3 plus 1 minus 1 by P3 minus 1. So when I mix up all these sums, then also you must be able to remember the formula. So if I use this formula, P1, 2 power 4 plus 1, 5 minus 1 by P1, 2 minus 1 into P2, that is 3. Power will be 3 plus 1, 4 minus 1 by P2, 3 minus 1 into P3, that is 5. Power will be power 3 plus 1, 4, then minus 1 by P3 is 5 minus 1. Now you have here 32 minus 1, that is 31 into 3 power 4, 81 minus 1, 80 by 2, 40. 5 power 4, 625 minus 1, 624 by 4, 156. This is the answer because in the option they have given or they have left the answer like this. So today we have done a few problems like this. Tomorrow we are going to do some more problems. Meanwhile, learn some more shortcut methods. Come to the class well prepared. See you again.